All right. Good morning, good afternoon, good whenever you're going through watching this presentation, hopefully sometime on Monday of this week. I'm here to talk to you guys a little bit about giving presentations. So I have created a presentation on presentations. Yeah, it sounds real dumb. Please forgive the incredible amount of meta that is currently occurring here. But this is a subject that I really don't think you get proper instruction on anywhere else. It's a subject that is near and dear to my heart. So I want to go through and help you guys out. And I'm going to give a little bit of discussion at the beginning. And then I'm just going to go through and I'm going to show you guys some example slides and discuss them and discuss highs and lows and things that I've seen that are done that are good and bad throughout the several years of watching these final design presentations that I've gone through. So into the intro, what is a presentation? I think this is the first and foremost thing we need to think about. Anytime you are presenting information, whether it is in an actual presentation similar to this via PowerPoint or without a PowerPoint with no slides, just talking in front of a group of people, maybe with a piece of chalk or a whiteboard or whatever it is, whenever you are presenting, you are trying to tell a story. You are trying to convey information in some way that is going to get your point and get your methodology and get your understanding across to an audience. Kurt Vonnegut wrote an essay years and years ago about the different shapes of stories and how they follow different patterns, different cadences, different shapes to the, and I guess as a shape, we're more talking about the cadence of excitement and of energy in the story. Typically, when students give a presentation and they talk, we get something along the lines of this, where it is a completely flatlined, monotonic nothingness that has nothing to incentivize the viewer to pay attention. However, there are common shapes. You have the four ones or the three others down here. Discovery and mystery are probably the two most common ones, along with the rags to riches type story in engineering presentations. Discovery is, I found a thing and then something didn't work, and then I found another thing and then something didn't work, and now look at where I managed to pull myself to. Mystery actually follows the same cadence as something along the lines of a Cinderella story. You go from the bottom of the barrel and you come up and you have hope and there is something great there, and then there's a catastrophe, there's a failure, and you go back down to a bottom point, and then you climb back out of it, and at the end of the day, everybody's living happily ever after. These general cadences and everything that belong to stories and belong to fairy tales and belong to whatever else apply to when I'm giving a presentation and I'm talking about my design, about my research, about whatever it may be. So as you are creating a presentation, think of it as a story. Think about it as you trying to tell your audience the tale of where you began and how you got to where you are. That is the first point to presenting. So now let's take a look at the outline for this semester. This is not actually this semester, this is, I believe, last semester's presentation requirements that I stole from last semester's Canvas page. This is not this current semester stuff. What your exact requirements are may be a little bit different. What I did here was I looked at my requirements and I broke them down into 3 subsections. And I actually took one of the subsections that was lower down and moved it up into what I call the good stuff. This is a 3-part presentation. I have some introduction. That's going to be a very baseline. It's going to be the low of my story. And then I'm going to have the good stuff. That is my rising action. That is me telling you the tale of how I got to this design, all of the things that went into it. And then I will have the finale, which is the final culmination, the climax, the highlights of, look at everything I did, and this is why it is so great. This is one example of how to go about doing it. You can take these and break them down into 4 or 5 sections. You can have ups and downs. You can have different patterns, different cadences. It's all up to you to decide how you want to go about doing it. This is one example. You do not need to copy it, and you do not need to go through all of your requirements in the exact order in which they appear in the requirements document. That's just pedantic. Go through them, discuss them, make sure you cover all of them, but cover all of them in a way that is engaging and that weaves them together in a way that makes sense. So now to demonstrate my point, I'm going to go ahead and I'm going to start off a presentation that will look very familiar to any of the presentations you may have watched from previous semesters of mechanical design. So today I'm going to start off with my outline slide. And I'm going to talk to you first about the first thing I'm going to talk to you about. And then after we get through that, I'm going to talk to you about the second thing I'm going to talk to you about. And as a part of this, we're going to discuss my first sub-item, and then we'll discuss my second sub-item. And then after we discuss this, I'm going to go into the third thing that I'm going to talk to you about, and then we'll get to our conclusions. Now, I'm going to talk to you about my Hedgehog concept. My Hedgehog concept is a bunch of words that I put on a slide with no other context other than to tell you that I came up with a Hedgehog concept for my presentation. That is all I am going to talk about here, and this slide doesn't really tell you as the viewer anything at all about my product. It just tells you that I met the requirement of making a Hedgehog slide concept slide. Now, let me give you a product overview. Yet again, I am going to have a bunch of words on slides, and most of these words are going to tell you a little bit about my product, but they're not really going to do anything to convey any significant amount of information. However, I am probably going to read through every single word on these slides and bore you to death as I read off bullet point by bullet point by bullet point by bullet point by bullet point, just to get across that I made an overview slide. So, at this point, hopefully you guys can understand just how absolutely terrible beginning your slides this way are. As a matter of fact, the Hedgehog concept slide and the product overview slide are actually slides with a little bit of tweaking that came from previous semesters of Mech 2 presentations. I literally copied and pasted them from other slides into here. These are exactly the types of things that I had to sit through when watching these presentations in previous semesters. It's terrible. So here is an alternative way of going about doing this. I'm going to completely skip the outline, and I'm going to do a completely different take on both product overview, at least from this, and from a Hedgehog concept to show you a different way of doing it. So first and foremost, I'm going to talk to you about the GMS F21. This here is, I am now starting off right off the bat with my presentation by giving you a product overview. What I have here are a couple of things. The first thing I have is my product name over here. I have a list of statistics or descriptors about my vehicle. And then each one of these highlights here is a part of my overview. So if I'm presenting this slide as though it were a slide, as though it were the first slide of my product, after my cover slide, my title slide, I would come in and say, I'd like to present to you the GMS F21. This is a custom vehicle designed to compete in Formula SAE competition. The total vehicle weight is about 625 pounds with driver. The engine makes about 70 horsepower. At 80 miles an hour, the car is able of achieving about 800 pounds of downforce. Throughout the rest of today's presentation, I'm going to go through and I'm going to break down a little bit of details on the driver controls, the chassis design, the aerodynamics, our powertrain, and our suspension to give you a little bit more understanding of what our vehicle is capable of doing. Now, if we compare this product overview slide and outline all combined into one to this product overview and this outline, think about it and assess which one is a more engaging slide for our audience and for people to watch. I would much rather, as an audience member, see something like this. There's a pretty picture. I have my scale bar included down at the bottom, which gives me a rough idea of the size of it. It's about 5 feet wheel to wheel. And if I can picture in my mind, okay, cool, that's 61 inches. If I turn it vertical, oh, the car's probably about 5 feet tall also. And it's a little bit under 5 feet wide. All of these things are things I can pick up just from looking at this picture, and I can see some statistics and some cool facts about the car. This is one option for an overview and outline slide. I made this slide, and this was originally where I had left it off, stealing information from the formula team, because as a co-faculty advisor, I have access to all of their information. But then I thought, you know what? I can do better than just this slide. This is a good starting point. However, I could go to here. And now my first slide has my vehicle, my design, my product central. And I have my same breakdown of all of my different subsystems, along with bullet points for each subsystem. So as I'm talking about what I'm going to tell you about for the presentation, and you're looking at my product and you're looking at everything on the slide, there's something visually engaging, there's information here. Note, only 2 of my bullet points are longer than 6 words. I actually think only 1 of my bullet points is longer than 6 words. And it's the one about custom molded steering wheel and seat inserts. And that's just because it would have been 2 lines to make a custom molded steering wheel and then custom molded steering in, or custom molded seat inserts. And that just made no sense. Everything else here is a quick little blip of information that now my audience is going to look at it and get an understanding of what I'm going to be talking to them about as I go through each system. And if you have a structures engineer that is watching this presentation, they might go, I don't care about aerodynamics. I don't care about suspension and tires. I don't care about their engine. I'm really interested in the steering wheel and this chassis design, because those are things where I can see structural impacts affecting things. And now they're going to know where to pay attention to certain facets that are going to interest them. And that's the goal, is to get them to pay attention to what is worthwhile for them to pay attention to. So now I've introduced my product. I've talked to you a little bit about what I'm going to talk to you about, these 5 systems that I'm going to discuss later in my presentation. Now I'm going to talk to you about what my product's motivations were. What was my motivation behind designing it? And so this is an alternative to the Hedgehog Concept slide. You'll note there's nothing on this slide that says Hedgehog Concept. Hedgehog Concept, and that terminology, is a niche concept from a singular book by a singular author who is a trained, well, he's a professor in business, but he goes around giving presentations, talking to companies about how to build their success. Hedgehog Concept is a buzzword. It's not what the actual concept means. The Hedgehog Concept is your motivation behind your design. It's the motivation, it's the things that you culminate together to make your design great. This is one example of a Hedgehog Concept slide where it conveys the 3 points of the Hedgehog Concept: best in class, passion, and economics. Those are the 3 things that make a good product. But over here, I just have 3 bullet points that talk about those 3 things separately. I don't go through details of them. I don't have Hedgehog Concept blasted loudly on the slide, because that term is meaningless outside of that one narrow thing. However, I'm still discussing my Hedgehog Concept here, just not explicitly stating it. This is actually a slide so this slide was made by me to get a point across. This slide was made by students last semester. I actually think that this was one of the best Hedgehog Concept slides that I saw, and I'm going to give them a little bit of flack for calling it Hedgehog Concept. But this goes back to the same things that I talked about before when designing a slide. There's an image here that showcases it, and I really like the fact that they have a hedgehog around it. It's cute, it's adorable. They have their 3 points of their Hedgehog Concept catered to here in this bottom, what they're looking for, what their passion, their primary focus, and their economics are all about. And they have a little bit of a blurb over here. Their words that they use over here. And the bullet points, their bullet points are all a little bit too long. There's too many words there. However, this is a clear and simple slide that you can discuss about in more depth as you're sitting on the slide and still be able to engage your audience by what you are saying, and with what is on the screen, not just by having a wall of text that you expect them to read and that you read off of it. So this is actually, like I said, the best Hedgehog concept slide that I can remember and that I could find from last semester's presentations. There are still things that can be done to improve it. However, this is not a bad example of one way to do this slide decently, we shall say. So now, record scratch, we're going to go back and we're going to look at this as my introduction. If we go back to, remember a few slides back where I talked about what my introductory stuff was going to be in my presentation, it was going to be my outline, my Hedgehog concept, a little bit of a product overview, kind of at the borderline overlapping there. So let's go and look at it. If we go back and we look at my different slides that I came up with and that I had here for this presentation, and I compare my original three, which all came from previous slides. You can go and dig around and find them, I'm sure. My outline slide, my Hedgehog concept slide, my product overview slide. But we compare them to the revisions that I created for a different product and everything there. Which ones would you enjoy watching and enjoy seeing presented? The first option is 3 walls of text. Nobody wants to sit through that. Nobody wants to watch that. It's terrible. And yeah, sure, if you're sending your slides to somebody else to review and to read, that's fine. But that's why the notes in PowerPoint exist. That's why those are there. You can write the notes down at the bottom when you send the slides to people. The opposite end of the spectrum is that I start off right out the gates with a product overview, a picture of my final design, pointers pointing to my key systems, little bits and blurbs about what those systems engage. And then I go into my motivations behind designing it. And then after my motivations, I could even go back to my product overview again, just to refresh my audience. I can play back and forth a little bit. It's all okay to do that. That's a part of telling a story. So you have to think about the cadence of things and where you want to interject information. However, I think everybody can agree that an introduction that starts off with my product overview and then my motivations and then gets into the details of my engineering is going to be more enjoyable to watch and to be a part of than a presentation where I'm just reading off of the same slides that you're reading off of. So now that we've covered this little bit of introduction, we've covered a little bit about some of the background for this, let's start talking a little bit more about some slides from previous semesters and the goods and bads of them. And so for right now, I've highlighted things on the slides, and as we get to later slides, there are fewer highlights just because things didn't quite fit right. But so let's talk about this slide. This slide came from one of the designs from fall 2020. And I'll come out right at the gates, and I will say they did a fantastic job of right off the bat coming and showing figures. This figure here shows their liquid handling. You can see, I can see clearly down in here, these pipettes sitting off of some sort of a holder on their rails, and it all looks good. This image over here shows how it all engages and fits into the entire overall assembly. The big problem here is that these figures don't show me anything about the details of the system. Great way to do this. Give me a section view right through the middle of one of these assemblies, or if not a section view, an exploded view. Show me the interior of your design. Show me how it works when you're talking about it. At the same time that they brought in these pictures, and they did an okay job with pictures, I feel like they just put in pictures for the sake of having pictures here, because they filled in everything else over here with a giant wall of text. Nothing in this wall of text tells me about how this system was designed. It doesn't tell me anything about requirements other than vague allusions to the fact that it must be in a BSL2 environment, and there are varying pipette applications, and that they're trying to fill trays faster. And they told me they use stepper motors. But that's it. That's all I got from this was a couple of vague details and no actual engineering about the system. So now if we switch to another one, another design slide, this is a little bit juxtaposed. Again, I have a great figure off here. And each of these figures, so if we compare these figures, there's nothing telling me what all the different parts of this assembly do. If I go here, well, now I have leaders pointing to the different parts and I can look at it and I can see how this goes together. I can understand how it works. Visually, I can see that and I can engage with it and go, okay, cool. They have a stepper motor over here that's attaching to this bearing. And that's going to be what, or this crank arm, that's going to be what drives the system over here. And it all attaches down to a lead screw. So I can picture, okay, cool. Here's orbital motion. Here's linear motion. I can picture double orbital. This is overall a significant improvement. However, there are still flaws. This slide was standalone. The words here on the right are added by me. This image was central. And so my blurbs here are, I don't see any calculations for the engineering for this system. There's nothing technical to get to it. And there's no mention of how it meets the requirements or showing how it meets the requirements or what its actual engineering specifications are and what it's capable of doing. So while it's better, it's still fundamentally flawed in that there's information still missing. And this isn't me trying to say that all of the information needs to go on a singular slide. You can have two slides where one slide is a description like this, where it breaks everything out, and then this image goes off to the side and becomes small, and you have more technical information on the next slide. That is perfectly fine. That is a very valid way of doing it. It's actually a great way of doing it. However, this slide did not have a follow-up with engineering specifications. This was a standalone description of this system. Another example of a slide. And now, so before I get into it, these slides, some of them came from designs where when Noel and I went through them, we were incredibly impressed with the designs and the quality of the designs and the engineering behind them. That didn't stop the slides from being absolutely horrible. And we had to dig to figure out where the merits were in these systems. You shouldn't make me dig to figure out why your stuff is good. Show me, convince me, make me believe. This slide right here starts off right off the bat, and I'm sure if you understand what I've been getting into before, you're going to see that this is a wall of text. It doesn't really tell me a whole lot about the system. They give me some good pointers. I can tell it's made out of 5052. That's great because it's a weldable aluminum alloy, and anybody who knows welding and knows fabrication is going to hopefully understand that little bit. There's 2 access openings. That's great. That means I've got easy access to it. And then hinged lid, awesome. But all these bullet points, all this stuff, I just have a wall of text here that I have to read in order to get through and understand the system and this breakdown and this overview of this one subsystem. And it's not enjoyable to have to stretch your brain to try and figure out what's going on here. And while there are nice things about this where they call out the specific O-rings, the design overall, just from this one slide, I would say is lackluster. Just because it's not giving me enough information to know what's going on with the design. So now, this is a slide. This slide and the following slide are slides that I've created from previous presentations. So I'm going to go ahead and toot my own horn and say I'm showing you slides that I've created. And we can juxtapose this to this slide. So this is a slide where I'm talking about a system and I'm breaking down the system and showing all of its key components. But then this slide wasn't followed up with any engineering. So now I'm going to show you a slide that breaks out all the parts of a subsystem, and then I'm going to have the engineering slide for it immediately afterwards, and I'm going to talk to you a little bit about that. Disclaimer here, these slides are far from perfect. I put them together in a day for a presentation because I didn't have enough time to get fully prepared for the presentation. So they are still lackluster, and there are still things that I would like to improve about the slides. However, I still think they are good examples for a slide. So on this page, I'm a tryhard. I'm going to admit it straight out. I hand traced the design of an espresso machine, and I made it in different layers so each of the different primary subsystems of the espresso machine could be highlighted independently. So from this slide, I can take my design, and by having certain things grayed out and certain things dark, I can highlight which components belong to the subsystem I'm going to be talking about. And then over here on the right, I have the names of the subsystems within my subsystem that are over here. So I can say that the group head team, which is one sub-design team, worked on the components that handled pretty much fluid transfer from the boilers to the exterior. That was their goal, was to make sure that whatever was generated inside could get to the outside. And these were the components and the small sub-assemblies that they designed. And now we're going to go and we're going to look at just the group head in particular, that one component. And here is a section view of the group head design with a load case for the user pushing down on it and all of my math that went into analyzing the system. So as I'm talking about this, I have all of my pointers for all of my math to describe how this one component works and how everything goes here. I have my pressure from my boiler that is providing pressure to drive water into the system. I have the pressure internally that is caused by my force, causing that internal pressure. And I can talk about how all of the fundamental mechanics of this system work as I am discussing this one subsystem's design. And if there are questions, if there are comments, this image I can go through, and I could have gone and hashed different things to show their different materials if I had wanted to. That's all something that's possible to do. But this is just one example of a system where I now have the math and the engineering behind it to talk about how my system works and how it achieves the goals that I set out to achieve. As I said, there could have been more information on here. There is some stuff missing. There could have been a little bit of background information, but it's not all that important. But this is just an example of how to talk about a subsystem and how to describe a subsystem. Here's a slide on how to describe a subsystem from last semester. An image of a refrigeration cycle system where there are leaders pointing to the key components of the system. And then there's math up here showing how they determined the requirements to meet the customer needs. They have the 7 degrees Celsius and the 4 degrees Celsius, along with how much power is going to be consumed to meet the heat transfer requirements. And then they show that the cartridge heater and all of the stuff has the capacity of meeting those requirements and going through doing it. And if I remember correctly from watching this presentation, they actually talked through a little bit more details about how they got to these numbers as they were talking about them. But overall, this was a fantastic example of how to convince me that your system was actually designed, and convince me with math and convince me with engineering proof that you did what we asked of you, instead of just showing me a picture with pointers going to things and saying, yeah, we did a thing. Because I'm not going to believe you. I'm sorry. I'm not actually sorry. I'm not going to believe you when you tell me you did a thing. Prove to me you did the thing. So I can believe you and I can trust your engineering judgment. Here is another example, I believe from the same group, of another subsystem design where they show where things are going to go, the motors that are doing it. They have the orbit arm here, and they show all of the design specifications along with their factors of safeties, the angular accelerations that they're getting, the total range. They have a usable mass. And when they were presenting this slide, they talked about how they got these numbers. So I could see these numbers, and I could probably back calculate from these numbers a little bit of what their claims were based off of their accelerations, their motor specifications, all of that, and say, okay, cool, does this make sense to me? They had enough information here that I could double check if I was skeptical. And that is a fantastic thing to provide to the person assessing your presentations. I'm always going to be skeptical. Dr. Traum is always going to be skeptical. The number of times Dr. Traum has called out heat transfer calculations and thermal calculations and fluids calculations is incalculable. And it's all because students didn't provide anything except for a single number, and he was able to pick them apart. But with providing more information, you begin to at least validate the fact that you put in effort and that you tried, instead of just trying to bullshit me. And I don't take kindly, and Dr. Traum doesn't take kindly to you guys trying to bullshit us. So this is, again, an example of a decent slide. I'm not going to say a great slide, but a decent slide from a previous semester in discussing a subsystems design. So now we're going to get into analysis. And I'm starting off with one of the worst of the worst of the worst slides that I've ever seen as an analysis slide. This slide is literally the simplest, stupidest, most basic analysis that you could conceive of. It is nothing more, and I'm going to draw it in cross-section so you can understand. I have a beam here. It is fixed on one side, and there is a force. I'm going to label the force as F. And now that is all this is showing me. Yet somebody wasted their time doing an FEA model of a beam where I could go into the back of my mechanics and materials textbook and find a closed form equation for how to solve this based off of the diameter of my lead screw. It's a waste of your time. It's a waste of my time to watch this slide presented, because this slide literally tells me nothing. It tells me that you made pretty colors in SolidWorks, actually, and that's about it, which is not awe-inspiring. It is not a mechanics of materials analysis. A mechanics of materials analysis would be the hand calculations. And as a matter of fact, I would rather see, at the end of the day, an image of this system put up here into a corner or up here into a corner with a free body diagram sitting over here showing me how you're loading it, and a hand calculation that you use to prove the deflections of the system just with a hand calculation for something this basic. There is not enough complexity here to warrant an analysis and to warrant an FEA model. It's just somebody attempting to meet a requirement and doing it so poorly that it made us angry. We saw similar analyses to these for 80/20. And if you watch any of the design presentations from last semester, you will notice myself and one of the representatives from Northrop Grumman, at least one of the representatives from Northrop Grumman, picking students apart for doing these simple, basic cantilever beam analyses and calling them an FEA analysis. No, if you're doing a finite element analysis and you're doing a full FEA model, have the hand calculations done. Show your hand calculations for what your loads were going to be on this slide. Show me what F is equal to. You know, what is L? What is I? These are all important things that I need when I'm looking at one of these analyses. Show me those informations. Show me that information. Show me the hand calculation that you did to determine this beam deflection. Now take whatever that was and bring that into a larger, fuller system analysis of an entire structure. And I'm going to go, great, you did the hand calcs. You understood the basic concepts of engineering, and then you applied it to a larger structure that's harder to analyze. That's exactly how you're supposed to do it. You're not supposed to use FEA for stupid shit like this. End rant. On the other side, on the flip side, here is actually a decent analysis slide. The only thing this slide is missing is a free body diagram, control volume schematic, image of the system, something to give me a reference for what is being talked about here. But right here, all right, cool. I can see immediately off the bat, there is linear conduction model. I have all of my variables in here. I have what my heat transfer rate is. This is literally perfect from the mathematical standpoint of showing me what I'm interested in and what I'm trying to do. Like I said, the only thing this slide is missing is a schematic that would show me where all these variables plug in so I can visualize it in the general context of the full assembly and of the full model. I don't have anything beyond that to say about this slide other than it's really close to being perfect. It's missing the one thing that I've already mentioned. Again, we go to an analysis slide for something that I did for my espresso machine symposium. Basic analysis for the time to heat up the water with an 800-watt heater, the massive steam that's going to be consumed in order to heat up milk to make a latte, just some basic stuff. There's a lot more behind this slide that I discussed when I was giving the presentation. But again, I show a little bit about my subassembly and what it looks like. I talk about all of my initial conditions here. I talk about the mass of my system and what I have going on here. And then I have my time to heat up my entire system to get what I'm trying to get out of it. Very simple, very basic discussion, simple analysis discussing how my system works. Here's another analysis. This is a little bit juxtaposed. It is way more complicated than the previous one. And you will note there are no numbers on this slide. This was all of the math behind a theoretical model to describe the flow of, what's the best? Actually, it was the flow of cells, actual human cells, in dispersed in a liquid medium through a capillary tube that was being used as a needle. So this was all the analysis and then a little bit of the data that came for it to back up the analysis for what went into the model that I developed to govern when these cells would end up reaching a high enough shear stress that they were going to die. So this is the first slide of two, and I don't believe I have the second slide in here because the data is not published and I'm not willing to show it in a video that will be online. However, this is the background behind another analysis. So this is a setup slide where the following slide would have the actual analysis results and the actual data and the actual numbers on it. It's just an example, again, of kind of a different way of thinking about how to do an analysis slide. So now we're almost at the end. I promise you are almost done with hearing me rant about slides. This is a customer needs slide. And yet again, as you guessed it, it came from previous semester, it came from last semester. And if you are squinting at this slide, trying to read it, you are not the only one. There is nothing in this slide beside these middle points that is easy to read and easy to understand. Better ways to do this would be having individual slides for each one of these groupings or having them be cascaded vertically where I can have larger words that are boiling down. There is a ton of wasted space off here and off here from making this all centralized columns. There are better ways of doing this slide, showing the customer needs are being met. I also don't have to do all of my customer needs being met on a single slide. A lot of groups did it last year, and a lot of the slides were just like this. They were bright and colorful and happy, and I couldn't understand shit because I couldn't read them because everything was so tiny. So when you're doing this and you're making a slide where you're going to have a lot of information on the slide, do me a favor. Take all of your stuff, put it on your screen, bump it up to full size, and then slide back about 5 feet from your screen. If you can't read what's on your screen at the point when you have slid back a few feet and you're squinting your eyes to try and read it, chances are your text is too small and you need to make it larger. Ways you can make it larger. A lot of this right here could have been broken off to the side and been spread out and made taller. There are options here. I'm not going to go into the nitty-gritty of how to fix this slide because there's about a dozen different ways to do it better. But this is just one more example of customer needs mapping where it could have been improved upon and it could have been done way better than this. Even if it takes 2 slides, or if you show for each subsystem a customer needs map for that subsystem, showing how it meets the subsystem needs and the subsystem requirements, that right there would achieve this goal. So there are options, there are other ways of doing this that would all work out. So that is the end of me having all the things I'm going to talk to you about when it comes to slides, when it comes to presentations. Like I said before, there are a lot of ways to go about doing this. You have tons of options here. There's a myriad of ways to go about it. At the end of the day, I'm going to go back and reiterate what I talked about at the beginning. When you are giving a presentation, you are telling a story, and you are trying to convince me and the rest of your audience about what you designed and the quality of your design and how it meets the requirements that were laid out in the customer needs statement, and even the ones that weren't necessarily stated there, but are still good to have and still necessary and still required. So think about it as not a debate. It's a sale, it's not a sales pitch. You are merely just trying to show that you did the work and you did your due diligence and that you did the engineering to properly design this system. And if you can convey that and make everything flow together, your presentations are going to be great. And on that note, I'm going to call it. I hope you all have a fantastic rest of your day. Good luck putting together your presentations, and I will see you around and or in final design presentations.